So thank you for everyone coming to the privacy talks. This time I'm very honored to invite Patricia from Toronto. So that's a very great talk about the future privacy and technologies, how we can preserve the human privacy based on the data and technology in the futures. So thank you for coming, Patricia, today.
Thank you so much, Fahe. It's an honor to be here.
Thank you. First of all, I'd like to introduce her background. She's a computer science PhD candidate at the University Toronto and postgraduate affiliated at the Vector Institute doing research on privacy, preserving the natural language processing with a focus on applied cryptography. Her research interests also include computational methods for the lost language decipherment. She is the co-founder and CEO of Private AI, a Toronto and Berlin-based startups, creating a suite of privacy tools that make it easy to comply with data protection regulations, mitigate cybersecurity threats, and maintain customer trust. Patricia is a recipient of NSERC Postgraduate Scholarship, the RBC Graduate Fellowship, the Beatrice Trixie Forsyth Graduate Scholarship in Computer Science, and the Ontario Graduate Scholarship. She has 8 years of research and software development experience, including at McGill Language Development Lab, the University of Toronto's Computational Linguistics Lab, the University of Toronto's Department of Linguistics, and the Public Health Agency of Canada. She is also a member of board directors of Equity Showcase, one of Canada's oldest not-for-profit charitable organizations. So yeah, it was great to have a talk with Patricia today. So yeah, let's move to the today's interview agenda. I was reviewed your startup, the companies, the private AI. I felt that your technologies, this startup's activity is very innovative, especially privacy industries. I'm wondering why did you start this company and what is your motivations, the background there?
Mm-hmm. Yeah, so we actually started my PhD in order to start a company, and at the very beginning, myself and my thesis advisor, what we're looking at in order to start the company was doing something in acoustic forensics. And acoustic forensics is for speaker profiling, identifying who is speaking in a recording, determining what their educational background, economic background, things like that are. And the reason we wanted to do it was to include that information in an automatic speech recognition system to really make the automatic speech recognition system good for subpopulations, because that is often a complaint about ASR. It turned out that the people who had the most interest in speaking to us about our research were often from countries that had less than ideal human rights records. So we wanted to do some research that was balancing the increase in amount of data, increase in specificity for technology, and also privacy. So we started looking at homomorphic encryption and combining that with natural language processing. We have some publications out of that. We tried to spin out a product with homomorphic encryption and NLP, but ultimately it didn't seem like it was going to scale to the level that we wanted to. So we went back to the drawing board. And we started looking at what was really lacking in the market. And we noticed this giant gap where there were no tools that were super easy to integrate, either on edge, so within app, within browser extension, within IoT, and on premise or on private cloud for preserving privacy. So that's where we came up with our first idea for a product, which is this de-identification toolkit that is super easy to integrate with 3 lines of code, and it could be used to de-identify text, images, video, and audio.
I understand. So from your experiences, so what is the most difficult topics for the enterprises to align those kind of the technologies for development?
The most difficult. So one, I think if you have enough money, it's finding the right talent in order to integrate it. And for a lot of cases, for a lot of enterprises, they won't have enough money to hire the right talent. So talent is sparse. So we need to we need to create tools that are really generalizable in order to solve this need.
I see. Yeah, do you also support just like educations or technical developments inside the corporations? Because if you are supporting those processes, that could be very helpful for the enterprises to fully comply with the privacy preserving.
So educational support within the corporations? Great question. So there are more and more resources available for people to learn. There's Open Mind, I believe, came out with a conference for learning about privacy preserving machine learning. There are more and more classes in universities about privacy technologies, though, you know, there still needs to be that talent gap even solved within faculty members for that to be a widespread offering. And there are more and more accessible resources for reading about privacy preserving technologies. So I think that's been helping. We ourselves do educate through publications and talks.
I see. Yeah, thank you for your updates. Let's move on to the next questions. You have been working as an engineers in the space. We also developed our own not-for-profit establishment, which is the Privacy by Design Lab. It's named after from the concept of Ankabukian as the proposed concept, the late of 2000s. So I'm wondering how these concepts is to penetrate in the engineering communities. Of course, you're based in Toronto, but I'm very happy to be known how it works, this concept among the engineer community since then.
That's a great question. So I think there's still a lot of getting used to the concept in the engineering community, but it is getting much more known. So it's something that once you've heard about it, once you've been immersed in it for long enough, it just seems like common sense. But I remember hearing about it in a talk that Anne Kavukian was giving in 2017. And it just struck me that it's something so clearly ethical and the right thing to do for developers was actually a concept that was very surprising and the first time that I was hearing about it in my education. So if we go back to 2009 when Privacy by Design was created, there were a lot of innovations that were actually really interesting coming out at that time. So Cynthia Dvorak, she came out with her pinnacle papers on differential privacy around 2008, 2009. Then there was the paper on fully homomorphic encryption by Gentry that came out in 2009. And in 2009, the Privacy by Design paper came out. So a lot of things bubbling, but nothing too practical yet, right? It was setting the stage for what we're seeing now as the privacy revolution, if you will. Around 2013, Snowden revelation came out. A few years later, there was Cambridge Analytica, and those two major scandals really helped put privacy on the map along with the GDPR. So now people are paying attention, and engineers are responding to that and learning about what to do in response to that. Based on a lot of the time, what they're realizing is more how to be more ethical within their own creations, and a lot of the time also getting pushed by the managers by saying, this is what we need in order to survive as a business.
Okay, I understand. Yeah, I'm just reviewing some of your publications on the Medium blog, which is very helpful. Even I'm not the engineering person. I'm coming from the business and policy making side, but it's a very easy to understand what's the concept of privacy preserving technologies. From your insights, I'm wondering about the natural language processing based on the privacy preserving. Since a lot of the company has developing some voice recognition technologies such as the smart speakers. This is the great example. Alexa, the Amazon, the Google Home, this Google. So what is the problems of the natural language processes in terms of privacy preserving concept? And what is need to care for the protecting the personal rights?
Great question. So the natural language contains probably the most sensitive information that we produce, right? Not only because of the content of what we're saying, but also because we can determine educational background, socioeconomic background, and many more things from speech. So having the problem with something like Alexa, right, where the developers were listening to snippets of conversations in order to debug a system, so they were saying that you as a user can delete all your previous recordings, great, can also opt out of this system where the developers are using your data to train their models, also great. The main problem there is that most people probably did not know that this was happening in the first place. So it's the difference between implied consent and positive consent. So explicitly asking a user, is it okay to use your data in this way?
I see. Yeah, it's the same problems for the business side. They have to commit to make the explicities agreement with the customers. For example, the privacy policy it's a very messy. Nobody's understand the free and the context what describes about the privacy. So those things will be similar to the internal operations of the new technologies. So I want you to succeed in the next topic is the very similar. We talk about the AI technologies everywhere. Every company is try to use this new automatic processing in terms of doing the business effective, doing the operation go together. I have reviewed your Medium blog, which is the very helpful, easy to categorize the concept of the privacy. So what is the current AI technology has problems of the privacy protections, and what kind of the support is necessary from the engineering side?
That's a very long question to answer. So we identified 4 pillars of what would take to create a perfectly privacy preserving system. And that premise already is very high, really high expectations. It's pretty much impossible to get perfect privacy, pretty much impossible to get perfect security, right? So take this as, in a very theoretical way, how would we go around doing this? So what would take is considering training data privacy. So the privacy of essentially the records or the people who are included in the training data. For example, if you're doing, if you're training on text, are there any social security numbers in there that you might want to not have your model memorize? And then there's input data privacy. So that's very much user privacy. What are they sending through the system? And same with output data privacy. What's coming out of the system from the prediction of the inputs? And then finally, there's model privacy. And model privacy is really to protect the bread and butter of the companies, which is pretty much also model security. But it's how much are you gathering from the model based on the outputs. For example, can you reverse engineer the model of weights based on the outputs, or can you access the weights because they're on your device and not encrypted? That kind of thing.
I understand. Yeah, that's very curious with me. So how did you define those 4 pillars? Because we see just in the specific products, but most of the people is unaware of the processings of the AI system. So I'm curious, what is the point to put the specific definitions of the 4 pillars from side?
Great question. So the point is, a lot of the time, what you hear is one privacy technology being pitted against the other. So homomorphic encryption over differential privacy, or differential privacy over anonymization, or secure multi-party computation is better than some other technology. And that is an entirely wrong way to think about privacy technologies. And the first way to show that is to show which problems are we solving and categorize them. And then, okay, now that we know the problems, which technologies fit into each of these categories to solve them? So differential privacy, really great for training data privacy, right? So is anonymization or de-identification, to a certain extent, anonymization as well. Differential privacy also great for output privacy in certain contexts, but it's really about, when you compare it with homomorphic encryption, how is homomorphic encryption going to preserve training data privacy if what you're doing is attacks trying to determine membership inference, right? It's not, right? So not suitable for that, but really great for protecting model privacy, for example. Really great for protecting input and output privacy.
I see. Yeah, I understand. Is that kind of the arrangement of the technology the best to fit it on the processes? So that's very clever to put aside of each element is. So I want to move to the next topic, which is the future landscapes. You involved many privacy enhancing the technology field so far, but a lot of company is looking at whether these technologies could be in a practice or not. For example, the Google is developing a differential privacy technologies for ad industries, and some research community is using these technologies for the census or any other output. So do you think that any specific industry will be able to use these technologies for the futures, or is there any problems that we need to overcome the technical issues?
Great question. So in terms of overcoming technical issues, one major gap is IoT devices, and it's really cool. Just recently, cybersecurity by design for IoT devices, I believe, was just required in the EU. So I guess we're going to get there soon. But without proper cybersecurity, which is a big technical challenge, we can't have proper privacy for the IoT devices. So that's one technical challenge we're solving. Another one is not we, but humanity solving, engineers are solving. Another one is there's still a lot of research to be done on how to create algorithms that work with homomorphic encryption, or algorithms that will balance out the accuracy loss by adding differentially private noise. So it's it's still a lot of stuff that needs to go through proper research in order to come out with actual things that can be used in industry. But in industry itself, things that have been in use are things like de-identification, differentially private gradient descent, and things like the Gboard to try to predict what kind of what you're typing. Then there's differential privacy to train models across multiple customer service departments across multiple companies, for example. So there are quite a few of these being used in practice, but there are still several technical challenges that are quite huge hurdles.
I understand. Yeah, that's very challenging for the enterprise size. Which parts they need to involve the first, and which part they invested the resources. Maybe not all the people is aware of this technology's impact for the futures, but the business side is the worry about the privacy, data protections, how they have to communicate with the customers to collect the data. So this is a challenges for all the institutions, not only for the private companies, the public sectors, of course, the individual. So that's a very great approach that you are in the practice at this moment. And you have published one great tool for the people who wants to make a practice based on the privacy enhancing technologies. For the even the beginners, how we can start to choose the privacy enhancement technologies for implementations?
Great question. So if you're interested in to learn a particular field, I generally find that the best way to go about it is by thinking of a problem and then working your way to solving that problem and learning along the way. So that's just my way of learning. If I have something concrete to tie the theoretical information to, I remember it much better. So I expect other people's brains, at least some people work like that too. So think of a privacy problem that you're currently facing, or that you think that somebody in your industry is facing, and then work your way towards solving it with the technologies that might be right for that problem. It might be a mix of technologies, and then you'll learn a whole bunch of things that you'll tie together, and it'll create better connections for you to remember what you're working on.
So in this case, even the non-technical companies, such as they haven't done a lot of the business, such as the Google and Facebook has the big data business at the times, but like a non-technical company, they want to develop the new products with using AI, the machine learnings. So how they have to start in the initial step, just like learning about the technology itself, or learning about the AI. So what is the best method for them?
Oh, okay. If a non-technical company wants to do that, are they okay? Okay. I think first of all, reading about all the applications, right, that are relevant to their industry. So I'm assuming a non-technical company is going to be able to eventually hire people to do this.
Oh, I see.
Or are they going to hire another company to do this?
I understand.
One or the other. So I think it's the main thing is understanding what the different kinds of AI are good for. So for example, it's not just reinforcement learning that's going to solve everything, or not just generative adversarial networks that are going to solve everything. So understanding what has been done in your industry with a particular machine learning algorithm or AI algorithm, and how it fits in, and then expanding from there after you've got a good grounding on what you already know and of the AI integrated into what you already know. And once you have a good picture of that, you might come up with problems that might be good for solving with the tools that you've read about, and then talk to people who do understand machine learning at a deeper level to try to see whether that your ideas make sense. So sounding board, and then hire a company to work on it for you, because if you don't have the technical background, you're not going to likely be able to integrate it yourself. So one really big difficulty for machine learning is deployment. It's getting the right data. So figuring those two out are sometimes even harder than figuring out what the right model is if it's already a problem that's been dealt with in the industry.
Yeah, I appreciate that very kindly advice for them, because a lot of the non-technical company wants to start the data business. However, the less literacies will be causing any problems in the futures. The technical solution is the one choice for them. Then for the market creations, maybe non-technical company needs to understand the privacy enhancing the technology as well. So that's a very great message for them. So lastly, could you give us the message to the older listeners? Maybe they are coming from non-technical part as well, just the government people or policymakers as well is seeing this technical concept. So please give a message for them.
Sure. So yeah, so for people who are non-technical who want to get more into this field, I would talk to as many people as possible about their expertise, try to understand where the technical folk are coming from, talk to lawyers who are drafting these legislations or thinking a lot about these legislations. So it's really about getting a well-rounded picture of what people think is possible, what is actually possible, and how this affects the law and how this is going to affect your company or your government. So if you are interested, I'm always happy to talk more with anybody who reaches out about questions, and also happy to point to the right individuals for different questions.
Yeah, thank you, Patricia, having this time. These are very great talks, the great insight from the experiences. I'm very happy to be shared the idea, and happy to reach the people who is interested in this technical fields.
Very happy to be here. Thank you so much, Kohei.
Thank you.